Hi everyone, welcome to part 3 of lecture 3. And in this part, we will cover the cumulative distribution function CDF. So remember the previous part, and we covered the PMF, right? And the PMF is basically used to calculate the probability of random variable. So what was the random variable? The random variables is used to associate some subsets to some numbers, right? So, for example, we said that we gave an example of rolling a die 2 times, and our interest was the sum of them, okay? And we created the random variables based on, let's say, the sum of the two rolls will be less than or equal to 3 or not. So we assign a random variables 1 and 0 if y, which is the sum of two rolls, is less than or equal to 3 and 0 otherwise. Okay? And then we have calculated the probability of x, the random variable, will be equal to 1. So in the total probability, I mean, the random variables in subsets is equal to individual probability of the random variables, right? The sum of the probability of individual variables. So this arises in a special case, which is if we want to calculate the random variables will be less than or equal to some number, okay? I mean, let's say instead of calculating the x is equal to 3, x is equal to 2, let's say I want to calculate what is the probability of x is less than or equal to 2. So if this is the case, I can use the CDF to calculate the probability of this inequality. So we call it cumulative distribution function, and it is denoted as f of x, right? Okay, so sometimes I will use only this this one, okay? So this is actually the f of x is equal to the probability of x is less than or equal to some random variable. And this is equal to sum of the individual probability of the random variables based on this condition. So xi will be less than or equal to desired x. So the CDF, if you calculate the CDF of a random variables, that contains all required information, okay? So you don't need to calculate the PMF if you calculated the CDF. I mean, in other words, if you know the CDF of a random variables, you can calculate the individual probabilities and which is the PMF, right? And also CDF of a random variable x satisfies some properties, should satisfy some properties. The first one is the f of x, as same with the probability, it will range between 0 and 1. So it cannot be less than 0 and it cannot be greater than 1. This is the first property. The second one, when x reaches to minus infinity, the limit of f of x will be 0. And if x reaches to positive infinity, and in this case, the limit of f of x will be equal to 1. And this is the second point, second property. The third one is f of x is non-decreasing function. That's mean if y is greater than or equal to x, then f of y should be greater than or equal to f of x. Okay, this is a non-decreasing function. And the last one is f of x is the right continuous function. So that's mean, let me show you in a graph. Let's say I have a graph like that. Okay, and let's say I specified a point A in here, right? So my x, when my x reaches to that point, the f of x and f of a should be same. But in the CDF, if I reach the a from the left side, these uh, will not be equal. Okay, f of x is not equal to f(a). That's why this function is a right continuous one. If this two if this two is not clear, please check your calculus lecture. Okay, so keep this four properties in your mind when you create a CDF of a random variable. So remember the experiment we did in the previous parts, and let's say we roll two independent die, the fair die, okay? And let's say our interest is sum of rolls. And we define the sum of rolls by y, okay? So, and then we calculated the PMF of the y as shown in here, right? So if the y is 2, that's mean if the sum of two rolls is 2, the probability is 1/36. So I will not go to the details of this calculation, but you can do it yourself to make it more clear. So by using this PMF, this individual probability of the random variables, you can create the CDF, the CDF of those random variables, right? So in here, this shows that, for example, if Py is equal to 4, I can look at the PMF, and if y is equal to 4, I can say that the probability of this condition is 1/12. So, but when we use the CDF, how they differ from the PMF? So if I ask you the probability of y is less than or equal to 4, in this case, you have to create the CDF of those random variables. So you at home, you will do the CDF of this experiment like that, okay? But to help you, I will give you some simpler example, and I will show you how we can create the CDF of such a problem, and then you can do this problem by yourself. Okay, so let's create a white page, and let's say we have rolling a pair die, a pair three-sided die 2 times. Okay, so a die can take, because it's a three-sided, 1, 2, and 3, right? So what is the smallest number a die can take? So the upward face will be the smallest one. So which is the 1, right? So the minimum sum can be 1 plus 1, and it is going to be 2, right? And what is the maximum of what is the maximum value of that die? It's 3, right? So if 2 dice take 3 and 3, the summation will be 6. So I can infer from this part, I can say that the summation of this three-sided 2 dice will be between 2 and 6, right? So my interest y will be greater than 2 and less than 6. Okay, here let me write all subsets here. It can be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and 3, 1, 3, 2, and 3, 3. So, and I want to calculate the CDF, right? So f of x, and which is equal to probability of x is less than or equal to something. Let's uh, start from the less than. And what is the smallest one? Is 2, right? And let's say this is, let's make it x. Okay. So the probability of x will be less than 2 is 0, right? Because the smallest one can be 2. It cannot be less than 2. And um, any of these subsets will satisfy this condition. That's why the probability is 0. So in the second one is probability of x is less than or equal to 2. So which subsets satisfy this inequality? Only this one, right? So any other subsets will be greater than 2. So only this subset satisfy this condition. So how can I calculate the probability? Remember it? So which is, so there's a number of elements in the subsets and the number of elements in the sample space. And I have 9 subsets in my sample space. So the probability will be 1 over 9, right? Because I have only one subset here. So the A is 1. So let's look at the other one, f of x is the probability of x. What is the other one? The other possible sums. It is 3, right? So there's x can be 2, 3, 4, 5, and 6. So with the 2, and now let's do the 3. 3. Okay, so I can write this one. Let me change the color. So I can write this part as the probability of x is less than or equal to 2 plus the probability of x is equal to 3, right? So I have already calculated this part, which is 1 over 9. So 1 over 9 plus, what is the probability of x will be equal to 3? So which one satisfies this equality? I think this one and this one, right? Yes. So I have 2 subsets, and that's why it's going to be 2 over 9. So which is 2 over 9, and it's going to be 3, 9. So let's do this, the other one, f of x, probability of x is less than or equal to 4. Okay, so, and again, I can write this part as probability of x is less than or equal to 3 plus probability of x will be equal to 4. So I have already calculated this one, which is 3 over 9, 3 over 9, and plus, what's the probability of x is equal to 4? Let's check the subsets. I think this one, and this one, and this one satisfy this equality, right? So I have 1, 2, and 3. So 3. So it's going to be 9, 6, right? So another one is f of x is equal to the px will be less than or equal to 5. And I can rewrite this part as probability of x will be less than or equal to 4 plus probability of x will be equal to 5. So I'm knowing this one because I have already calculated this here. plus the, and to calculate this one, the probability of x is equal to 5. Let's check the subsets. So this one and this one, right? Satisfy this equality. So which is 2 or 9, right? Because I have only two subsets satisfy this equality. So which is going to be 8, 9, right? So it's going to be 8, 9. And the last one is the last possible values x can take is the code of x is less than or equal to 6. So, and this can be written as this part. The probability of x is less than or equal to 5 plus probability of x is equal to 6. I have also to calculate this one, which is 8, 9 plus what is the probability of x is equal to 6. So there is only one point here that satisfies this equality, so which is a 1 over 9 and which is a 9 over 9. So I know all this all these probabilities, right? The CDFs. So let's create the graph, the CDF graph. Let me write from this point. This is the one, and let's say that is okay, something like that. And what was the probabilities here? Let's say um 1, 3, 6, 8, 9. So let's say this is the 1, this is the 3, this is the 6, this is the 8, and this is the 9. So which is 1 over 9, 3 over 9, 6 over 9, 8 over 9, and 9 over 9. So which is 1. So let's say this is 2, 3, this is 4, this is 5, and this is 6. So let me change the color. So if x, so this is the x, right? That is x, and that's the fx. So if that's less than or equal to, so it is less than 2, so the probability is 0, right? 0. So if it is less than or equal to 2, it will jump to this point, and the probability will be 1 over 9 until the point 3, that 3 will not be included. And at 3, I will jump to this point, and the probability is 2 over 9 until it reaches to 4, right? And at 4, it will jump to this point. And it will goes until 5, right? So, and at the point of 5, it will jump to this point. So this point, and the probability will be 8 over 9 until the point 6. And at 6, it will jump to that point. Okay? And after that point, it could be 1. So this is the CDF of this one. So we can deduce some useful things from the CDF graph. So we can say that the f of x cannot be greater than 1, okay, and it cannot be less than 0. So this is the first property of the CDF. And also, um, it's a right continuous function, right? So when I reach, for example, that point from the right-hand side, the f of so f of x and f of a will be same, like this point. If I reach from this point, so I will get the 1. But if I reach this point from the left side, it will not be continuous because there's a jump here. So this point has, this point has no value. Okay, I mean, so if I reach to this point from the left hand side, okay, when I reach to this point from the left hand side, and let's say this is the point A, f of x will be 8, 9, but f of a is actually 9, 9. So they are not equal. So they are not equal. So that's why this function is not left continuous. And also think about this jumps. Okay, how we can extract these jumps. So what is the height of this jump is 3 over 9 minus 1 over 9, right? And this is 2, 9. And what is this? Actually, this is the probability of x is equal to 3, right? Okay, let's look at this one, this one, this one. So these are the jumps. Okay. So for example, let's look at this jump here. So it jumps from the 6 over 9 to 8 over 9. So this jumps is actually the probability of x is equal to 5. Okay. So by using the CDF, as we said in the previous slides, you can calculate any kind of probability, like individual probabilities of some inequalities. So this is the CDF, and this is how we can create the CDF of the random variables. And as I said, please do this. So where is it? Please do this at home, and be sure that you understand the CDF clearly. So at least you have to understand the basic logic of the CDFs. And also we will try to solve this question at class. Okay, that's it. And I will see you in another part. And I think we will continue with the mean of the discrete random variables. And in the last part, we will continue with the variance of the discrete random variables. So I will see you in the next part.